The Seaman's Friend, Part 1, Chapter 1, General Rules and Observations, Construction of Vessels, Tonnage and Carriage of Merchant Vessels, Proportions of the Spars, Placing the Masts, Size of Anchors and Cables, Lead Lines, Log Line, Ballast and Lading. Construction of Vessels. As merchant vessels of the larger class are now built in the United States, the extreme length of deck, from the after part of the stern post to the fore part of the stem, is from 4½ to 4 3/4 that of the beam, at its widest part. The Damascus, of 700 tons measurement, built at Boston in 1839, and considered a fair specimen of our best freighting vessels, had 150 feet from stem to stern post, and 32 feet 6 inches extreme breadth. The Rajah, of 530 tons, built at Boston in 1837, had 140 feet length and 30 feet beam, being each in length about 4 6/10 their beam. A great contrast to this proportion is exhibited in the most recent Statistics, 1841, of vessels of the same tonnage in the English Navy, as the following table will show. Of the English Navy, the Dido, 734 tons, deck length 120 feet, beam 37 feet 6 inches, proportion 3.2. The Pilot, 492 tons, deck length 105 feet, beam 33 feet 6 inches, proportion 3.13. The Alert, 358 tons, deck length 95 feet, beam 30 feet 4 inches, proportion 3.16. Of the American merchantman, the Damascus, 694 tons, deck length 150 feet, beam 32 feet 6 inches, proportion 4.6. The Rajah, 531 tons, deck length 140 feet, beam 30 feet, proportion 4.66. These may perhaps be considered the extremes of shipbuilding, and between these there is every grade of difference. Tonnage and carriage of merchant vessels. The amount a vessel will carry in proportion to her tonnage depends upon whether and to what extent she is full or sharp-built. A sharp-built vessel of 300 tons measurement will carry just about her tonnage of measurement goods. A sharp-built vessel of 200 tons or under would probably carry less than her measurement. If over 400 tons, she would increase gradually to 50% above her measurement. A sharp-built vessel of 600 tons is generally rated at 900 tons carriage. A full-built vessel of 300 tons, after the latest model of American freighting vessels, will carry 525 tons, or 75% above her measurement, and one of 500 tons would carry full double her measurement. The following table may give a pretty fair average. Tons of measurement goods. 300 tons, full built, 0.75, or 525 tons. Sharp built, 0, or 300 tons. 400 tons, full built, 0.8, or 725 tons. Sharp built, 0.4, or 560 tons. 500 tons, full built, 1, or 1,000 tons. Sharp built, 0.5, or 750 tons. 600 tons, full built, 1.33, or 1,400 tons. Sharp built, 0.5, or 900 tons. Proportions of spars. There is no particular rule for sparring merchant vessels, some being light and others heavy sparred, and some having long topmasts and short lower masts, and others the reverse. The prevailing custom now is to spare them lightly, the main yard being a little less than double the beam, and the others proportioned by the main. Most merchant vessels now have the yards at the fore and main of the same size, for convenience in shifting sails, so that the same topsail may be bent on either yard. The following table, taken from the Seaman's Manual, will show the average proportions of the spars of merchant vessels of the largest class, as formerly built. Mainmast, 2.5 times the ship's beam. Foremast, 8/9 of the main mast. Mizzenmast, 5/6 of the main mast. Bowsprit, 2/3 of the main mast. Topmasts, 3/5 of the lower masts. Topgallant masts, 1/2 the length of their topmasts. Jib boom, the length of the bowsprit. Main yard, twice the beam. Foreyard, 7/8 of the main yard. Main topsail yard, 2/3 of the main yard. Fore topsail yard, 2/3 of the foreyard. Crossjack yard, the length of the main topsail yard. Topgallant yards, 2/3 of the topsail yards. Mizzentop sail yard, the length of the main topgallant yard. Royal yards, 2/3 of the topgallant yards. Sprit sail yard, 5/6 of the fore topsail yard. Spanker boom, the length of the main topsail yard. Spanker gaff, 2/3 of the boom. For the thickness of the spars, the same book allows for the lower masts 1 inch and 1/4 diameter at the partners, for every 3 feet of length, and 9/10 in the middle, and 2/3 under the hounds, for every inch at the partners. For the yards, 1 inch at the slings, and 1/2 an inch at the yard arms, within the squares, for every 4 feet of the length. For the breadth of the maintop, 1/2 of the beam, and of the foretop, 8/9 of the maintop. The following are the proportions of the spars of the ship Damascus, before mentioned, built in 1839. Mainmast, 74 feet, head 11 feet 6 inches, size 26 inches. Foremast, 70 feet, head 11 feet 6 inches, size 25 inches. Mizzenmast, 68 feet, head 8 feet 6 inches, size 18 inches. Main and fore topmasts, 41 feet, head 6 feet 6 inches, size 14.5 inches. Mizzen topmast, 32 feet, head 5 feet, size 9.5 inches. Main topgallant mast, 23 feet, 15 feet with 2-foot head, size 9.5 inches. Fore topgallant mast, 21 feet, 14 feet with 2-foot head, size 9.5 inches. Mizzen topgallant mast, 17 feet, 11 feet with 18 inches head. Main and fore yards, 60 feet, yard arms, 2 feet 6 inches. Main and fore topsail yards, 48 feet, yard arms, 3 feet 6 inches. Main topgallant yard, 37 feet, yard arms, 2 feet. Fore topgallant yard, 34 feet, yard arms, 2 feet. Main royal yard, 27 feet, yard arms, 1 foot 6 inches. Fore royal yard, 24 feet, yard arms, 1 foot 6 inches. Main skysail yard, 17 feet. Fore skysail yard, 15 feet. Crossjack yard, 44 feet. Yard arms, 2 feet. Mizzen topsail yard, 35 feet. Yard arms, 2 feet 9 inches. Mizzen topgallant yard, 25 feet. Yard arms, 1 foot 6 inches. Mizzen royal yard, 16 feet. Mizzen skysail yard, 10 feet. Bowsprit outboard, 27 feet. Size 26 inches. Jib boom, 42 feet, head 3 feet, size 14.5 inches. Flying jib boom, 40 feet, head 3 feet 6 inches. Main pole, 12 feet, 10 above royal mast, 5 inches in the cap. Forepole, 11 feet, 9 above royal mast, 4.5 inches in the cap. Mizzenpole, 9 feet, 7 above royal mast. Spanker boom, 40 feet. Spanker gaff, 30 feet. Swinging booms, 40 feet. Topmast studding sail booms, 34 feet. top gallant studding sail booms 27 feet, yards for due 17 feet. Placing the masts. For a full-built ship, take the ship's extreme length and divide it into sevenths. Place the foremast 1/7 of its length from the stem, the mainmast 3/7 from the foremast, and the mizzenmast 2/7 from the mainmast. If a vessel is sharp-built and her stem and sternpost rake, her foremast should be further aft and her mizzenmast further forward than the rule of sevenths would give. A common rule for placing the foremast is to deduct 3/5 of a ship's beam from her length for the curvature of the keel forward, which is called the keel stroke, and place the mast next abaft the keel stroke. Size of anchors and cables. Various rules have been adopted for the weight of a ship's anchors. A vessel of 100 tons will generally have a best bower of 600 weight and a small bower of 500 weight, the weight of both being 11 pounds to a ton of the vessel. As a vessel increases in size, the proportion diminishes. A vessel of 700 tons will usually carry a best bower of 2,700 weight, a small bower of 2,400 weight, the weight of both being 7.5 pounds to a ton of the vessel. The stream should be a little more than 1/3 the weight of the best bower. The anchor stock should be the length of the shank. Its diameter should be half that of the ring, and its thickness 1 inch at the middle and half an inch at each end for every foot in length. Chain cables are usually 90 fathoms in length for large-sized vessels, and 60 for small vessels, as schooners and sloops. The regulation of the United States Navy for chain cables is 1.5 inches for a sloop of war, and 1.25 for brigs and schooners. In the merchant service, a ship of 400 tons would probably have a best bower cable of 1 5/6 and a working bower of 1.25 inches. A ship of 700 tons would have a best bower of 1 5/8 and a working bower of 1.5 inches. Chain cables have a shackle at every 15 fathoms, and 1 swivel at the first shackle. Some have 2 swivels, and formerly they were made with swivel between each shackle. Lead lines. The hand lead weighs usually 7 pounds, and the hand line is from 20 to 30 fathoms in length. The deep sea lead, pronounced dipsy, weighs from 14 to 18 or 20 pounds, and the deep sea line is from 90 to 110 fathoms. The proper way to mark a hand line is black leather at 2 and 3 fathoms, white rag at 5, red rag at 7, wide strip of leather with a hole in it at 10, and 13, 15, and 17 marked like 3, 5, and 7, 2 knots at 20, 3 at 30, and 4 at 40, with single pieces of cord at 25 and 35. The deep sea line has 1 knot at 20 fathoms, and an additional knot at every 10 fathoms, with single knots at each intermediate 5 fathoms. It sometimes has a strip of leather at 10 fathoms, and from 3 to 10 is marked like the hand line. Log line. The rate of a ship's sailing is measured by a log line and a half-minute glass. The line is marked with a knot for each mile, the real distance between each knot being, however, 1/120th of a mile, since a half-minute is 1/120th of an hour, a knot being thus the same portion of a mile that a half-minute is of an hour. The number of knots carried off while the glass is running out will show the number of miles the vessel goes in an hour. Many glasses, however, are made for 28 seconds, which of course reduces the number of feet for a knot to 47 6/10. But as the line is liable to stretch and the glass to be affected by the weather, in order to avoid all danger of a vessel's overrunning her reckoning, and to be on the safe side, it is recommended to mark 45 feet to a knot for a 28-second glass. About 10 fathoms is left unmarked next the log ship, called stray line. The object of this is that the log ship may get out of the eddy under the stern before the measuring begins. The end of the stray line is marked by a white rag, and the first knot is 45 or 47 feet from the rag. A single piece of cord or twine is put into the line for the first knot, 1 knot for the second, 2 for the fourth, 3 for the sixth, and so on, a single piece of cord being put in at the intermediate knots. Ballast and lading. A ship's behavior, as the phrase is, depends as much upon the manner in which she is loaded and ballasted as upon her model. It is said that a vessel may be prevented from rolling heavily if, when the ballast is iron, it is stowed up to the floorheads, because this will bring the ship back, after she has inclined, with less violence, and will act upon a point but little distant from the center of gravity, and not interfere with her stiff carrying of sail. The cargo should be stowed with the weightier materials as near as possible to the center of gravity, and high or low, according to the build of the vessel. If the vessel is full and low built, the heavy articles should be stowed high up, that the center of gravity may be raised and the vessel kept from rolling too much, and from being too laborsome. But a narrow, high-built vessel should have the heavy articles stowed low and near the keelson, which will tend to keep her from being crank, and enable her to carry sail to more advantage.